Right, okay. Then today our topic is to learn about formulating iterative formula and to observing the exact, what do you call that, solution for a quadratic, whatever the solution of a equation. So the topic is the iteration formula. Iteration formula and solution for equations. That is the second part of the numerical analysis, right? So we know that whatever some kind of like this, the suppose that it's a kind of a function over here is fx. If it is exists in between x1 and x2. So if the sign changes over here, we know that the solution for fx locates in between x1 and x2. Right. Now our problem is that how to find the exact solution. How to find the solution to more accurate answer. More accurate answer. That is a fact. For this method, this is called the numerical methods. For this numerical method, there are a lot of numerical methods are there. But in our PO3 curriculum, we learn the method of iteration. Using the iteration formula, how do you get the solution for any kind of equation for that? Now problem is, now you may be thinking that why do we have a lot of methods to get the numerical what you call solution for a some kind of equation. So the answer is because you know that as different numerical methods are applicable for different type of equation, but certain numerical methods are not applicable for certain one. Sometimes certain numerical methods take long steps to get the correct answer, and sometimes from certain numerical methods you can't get the exact solution for that. It will be just like it's oscillating and those properties are there. Because of that, we use different numerical methods for this, but in our curriculum we learn only one method, the iteration formula. Right, okay. How we did this is iteration formula is the step one is locate the solution. What do you call the locate the solution? We identify what are the, like in between which two figures this answer exists. That's the step one. Step two, form the iteration formula. Iteration formula. Step three, actually this iteration formula is a recurring formula. It's a recurring formula. What do you call recurring formula means? You can start with the one value when it proceeds recurring using the previous step of answer. That is what you mean by the recurring formula. When you're doing a question, you will understand what you mean by this. Step three is start with one boundary of selected location. You can use like locate in between x1 and x2. You can use either x1 or x2 as a initial value to start this iteration formula. That is the starting point of this iteration formula. When you proceed with the question, you will understand what I mean with this. Then you can say step 4, repeat the process until you get the solution, up to the required decimal point, up to the decimal point. When you're working out with this, you will understand that how to find this up to the required decimal point, right? Okay. We'll start with this. From a first example, I will just use this one. Then they mention the first example is fx equals to x squared minus 4x plus 1. The equation is fx is equals to x squared minus 4x. Actually, for to solve this equation, on it of having the iteration formula, because you can straightforward get it, we use this equation just like this. If it is a question like this way around e to the power x plus sine x plus 2x, so like different kind of alterations are there, you can't simplify this kind of situation. For them only we use this numerical methods, but not to solve this kind of easier equation. For this one you can straightforward put the formula and obtain it. But we use as an initial step of to understand the question, right? Okay. Then they mention show that the equation fx equals to 0 can be written in form of this. We need to show x equals to 4 minus 1 of x. We need to generate this. This is the one. So fx equals to 0 means x squared minus 4x plus 1 is equal to 0. Now look into this answer. Here we need to show this answer 4 minus 1 over x. So I will just like this, but I'll get this answer. X squared is equals to 4x minus 1. Okay, because I need to what I need to form is 4 minus x equals to 4 minus 1 over x. This you have to convert into this format. That's a requirement. Then I will divide both sides by x. Then what do you get? With x squared divided by x is equals to 4 minus 1 over x. So this is the initial step. Right? We have already proved this one. Fx as a root in the interval of 3 to 4, use the iterative formula. Now they have given the iterative formula, part B. This is part A. Using this is the iterative formula, this generation of iterative formula actually. You can write this is xn plus 1. This is the way of writing it. 4 minus 1 over xn. They initially mentioned x is in between 3 to 4. X is in between 3 to 4. So the location is 3 to 4. Right. Using this much to x naught equals to 3 to find the value for x1 and x2 and x3. So from this example, they mention initial point. You can see, look at this. They ask us to use x naught equals to 3. Here. X naught equals to 3. Right. Okay. Then initial boundary is given, this one. Sometimes it might be this or this, right? Okay. Now we need to find the solution for x1. This is a way of getting it. This iteration formula where we learn x1. If this n plus 1 is 1, n is equal to 0. Therefore, you can write this is 4 minus 1 over x naught. Then what is the first answer? 4 minus 1 over 3. Then you can say 4 minus 1 over 3. That answer is this bit. 3.66. So if this is a way of understanding this question. So if they ask us to find this one, find the solution up to 4 dp. If they ask in this answer, first 4 dp, we should write this answer to correct to 3 decimal points. 46667. We need to write for 5 decimal points. That is the logic of getting this answer. Just keep this answer. Then just keep some space over here. Then x2. x2 is, if this n plus 1 is 2 means n equals to 1. That is 4 minus 1 over x1. That is how much? 4 minus 1 over 3.6667. You can say 4 minus 1 over, you can just put the answer. Then you get the answer, this one. 3.7272. If you need for 4 decimal point, write for 727. Keep this answer in this format. Right. Then x3. For this question, there's nothing to worry. They need to find only x1, x2, and x3 only. Right. Right. So this case, x3. x3 is 4 minus 1 over x2. That is 4 minus 1 over 3.72727. The next answer is 3.73171. Okay, right. Then if you need this answer to 4 decimal points, but I will get this like we'll get to make it 3 decimal points. I'll get it. Other than that, it's just kind of confusing. But if it is come up with the 4 decimal points, 3 decimal points, there you should write with only yeah. So this is turned up to 7, and this is turned up to 3. Right. Then what you need to do is round off this answer to 3 decimal points. Then what do you get with it? 3.667. And this answer 3.27, sorry, 3.727. Now check whether these answers are similar. Is this answer similar? No, they are not similar. Therefore, go to the next level. Then if you round it for 3 decimal points, what is that answer? 3.732. Are these answers similar? No. Therefore, you have to go further. Is that clear? Then you can go ahead with x4. x4 is how much? 4 minus 1 over x3. So if you just do this, you get that answer. That is this bit. 3.7320. So its answer is 3.732. Now, what you can say for the 2 consecutive answers should be similar. You can see these 2 answers are similar. They are similar. Therefore, you can write answer with the root correct to 3 dp. 3 decimal point is equals to 3.732. Is the answer for that. That's a way of getting this answer, right? Okay. Yeah, this is a way of understanding the first part of it.
So the mic.
In this question, let's see what happens if you start with the other boundary, because we start the first boundary as 3 as a x naught. So if you start with the second boundary, let's see what will happen to this answer. So I can say x1 is equal to 4 minus 1 over x naught. That is 4 minus 1 over 4. It's turned up to 3.75. 3.75, it's exactly 3.75. We are going to get the answer for 3 decimal points. Then if you come up with x2, x2 is 4 minus 1 over x1. That is 4 minus 1 over 3.75. Let's see what will happen today. 4 minus 1 over 3.75. That is 3.733. 3.733. If you need for 3 decimal points, you write for 4 decimal points. Then x3 is 4 minus that same answer. That is answer 3.733. So that answer is 3.7321. x4. Yeah, 3.7321. So obviously this answer is correct. Then if you starting with x3 or x4, it doesn't make a problem. You get the same answer. So it's not a problem with starting with whatever the boundary for this question. Remember that property is isolated for this problem, right? We'll go ahead with another couple of questions and see whether how it comes, right? Then this question, right? Fx equals to x cube minus 3x squared minus 2x plus 5. I will start with a new page. Fx equals to x cube minus 3x squared minus 2x plus 5, right? X plus 5, right? Show that equation fx equals to 0 has a root in between 3 to 4, right? Okay. Then what you need to do is you have to show that it exists in between 3 to 4. Then what we can get here is that initial I can put f3. F3 is 3 cube minus 3 times of 3 squared minus 2 times of 3 plus 5. So this answer is, this two get cancels, minus 6 plus 5 is minus 1. And if I put F4, 4 cube minus 3 times of 4 squared minus 2 times of 4 plus 5. That is 4 cube minus 3 times of 4 squared minus 2 times of 4 plus 5. It's 30. Now what you can see, Pute, now the sign changes. So you can say when x goes from minus 1, sorry, goes from 3 to 4. 3 to 4, the sign of fx changes. Therefore, therefore a root for fx exists between 3 and 4. That is the way of writing the answer for this question. Right, okay. Now that is the part A answer, right? Then part B, use the iteration formula. Here they have given the iteration formula for this, no need of generating it. So they have given x n plus 1 equals to square root of x cube minus 2xn. Xn cube minus 2xn plus 5 divided by 3. Divided by 3. They ask us to start from x naught equals to 3. We'll go ahead with this. And the second part of the question, they ask us to start with x naught equals to 4. Now let's see. In previous question, it doesn't make a sense because from the both boundaries, you get some kind of a diverging answer, sorry, converging answer into a certain value. Like let's work out with this. So x1 is equal to how much? Here this is x0 cube minus 2x0 plus 5 divided by 3, the square root of it. So it's turned up to 3 cube minus 2 times of 3 plus 5 divided by 3, the square root of it. So we'll work out and see what you get here. The square root of that is 3 cube minus 2, 3 plus 5 divided by 3. So the first answer is this one. 2.9439. I'm going to get it for 3 decimal points. So therefore, I just write it for 4 decimal points. Then x2. X2 would be how much? You can say, you can replace 3 instead of, 2.9439 instead of this. X1 cube minus 2x1 plus 5 divided by 3. I'm not writing that answer because you can replace this x1 means this answer over there, right? Then I'll just straightforward put to the calculator and get it. But other than that, it takes a little bit of long time to do this. That answer is 2.8651, right? Then if you write it for 3 decimal points, what is that answer? 2.944. If you write it here, 2.865. So they are not similar. That means you have to go further. Right. Then see whether what is that answer. Then x3. Same. I'm just not going to substitute over here. If you want, I can write it. 2.9439 cube minus 2 times of 2.9439 plus 5 divided by 3. The next answer is next answer is 2.7561. So the answer is 2.756. These two are not similar. Therefore, you have to go further. X4 is 2.6092. 2.609, right? X5. This answer is 2.4183. That is 2.418. Still, they are not similar. That means you have to go further with it. Right? X6. 2 2.1837, 2.184. No, x7 is again 1.9189. So the answer is 1.918919. Okay, x8 is this 1.656. 6561. So the answer is 1.656. Then x9 1.4410. 1.441. Down back. Still, it's not possible. Then x10 1.305. 1.3051. That is 1.305. Still, it's not there. x11 1.2400. That is 1.240. Still not there. Right. x12 is 1.2147. That is 1.215. x13 1.205. 1.2059. That is 1.26. Now you can see it's coming kind of like closer to each other. x14 is 1.2030. That is 1.203. Now it's come a little bit closer, a bit further. 1.2029. That is 1.2039. Yeah, it comes. You can see now what is the technical difficulty we come up when you're working out with this. You can see you need more number of steps to get the answer. It's converged into 1.203 after how many steps? 15 steps. That is why sometimes we do not go ahead with method of iteration because it takes long steps to get this answer. Understood? Pute? Right. Okay. Initially, yeah, that's a initial step we have been to work.
To the mic.
What we need to understand is, we need to see what happens if you start with x naught equals to 4. Right. Okay. Let's see. The function is it's you can say x n plus 1 is equal to square root of xn cube minus 2xn plus 5 over 3. That was the equation where we need to use. Right. Okay, we'll start with x1. x1 is equals to the same fact we can use. I'm using straightforwardly, just put these figures. 4 cube minus 2 times of 4 plus 5 divided by 3. This is 4 actually. With this you get the answer. Square root of 4 cube minus 2 times of 4 plus 5 divided by 3. So that answer is 4 point. Now look at this. Turn up to 4.5092. Now x2 is the replacement of that. 4.5092 cube minus 2 times of 4.5092 plus 5 divided by 3. So if you replace this, that is 5.4058. Then x3 is, if you just do this, you get the answer 7.121. Then x4 10.831. 319 x5 is 20 point. Now what you can see, Pute, the answer it's not converging, Pute. This is called diverging. It's going deep and deep. It never come up to a valley. So its answer is not converging. You can say answer is not converging. Converging. That means therefore x naught equals to 4 is not a suitable value to use in this iteration formula. This iteration formula. That's what we have to understand with this question. Is that clear? Right. Hopefully that is fine. Let's go ahead with this question, Pratik. The first part of is fx equals to x squared minus 6x plus 2. Show that this answer. So now let's see how to do this part of it. I just get the first part of it is this way. Anyway, I need to show x squared plus 2. So you can see that terms are there. So fx equals to 0. Fx equals to 0 means the starting equation is x squared minus 6x plus 2 equals to 0. So anyway, I need to show this. In that case, what can I do here is I will keep this x squared plus 2 here and bring this 6x to other side. Then you can say x equals to x squared plus 2 divided by 6. It's not solving. Actually, we are getting some kind of a formula based on that. Okay. When you come up with this, how are you supposed to do this? You can say here there's a square root there. That means you need to isolate x squared in one side. 6x minus 2. Then you can say x equals to square root of 6x minus 2. That's a way of getting this answer. Okay. Then for this case, what can you do? Initially, I just said the same thing. 6x minus 2 and then divide both sides by x. Then what do you get with it? 6x minus 2 divided by x, that is turn up to x equals to 6 minus 2 over x. That is a way of getting this kind of iteration format. So you'll be a little bit of a careful about that. Sometimes they may ask you to do it with it. Right. Then starting with x naught equals to 4, use iterative formula to find the root of the f equals to 0. Round your answer to 3 decimal points. Right. Okay. We'll go ahead with this with it. The first equation, x squared plus 2 over 6. So you can write xn plus 1 is equals to iterative formula is xn squared plus 2 over 6. They ask you to start with x naught equals to 4. Yeah, let's go ahead with this. X naught equals to 4. Therefore, x1 is equals to 4 squared plus 2 over 6. Let's work out and see. We need to get the answer for correct to 3 decimal points. That's what they expect us to do it. 4 squared plus 2 divided by 6. The first answer is 3. 3, we need to for 3 decimal points to put this, so I can write this way. X2 is if you replace with this, so what do you get? 3 squared plus 2 over 6. Then what do you get? Get the answer? 3 squared plus 2 over 6. So you get the answer. This is 3 squared plus 2 over 6. That is 1.833. 8333. Correct to 3 decimal point. Answer is 1.833. X4, X3. X3 is if you replace with that. Answer is 0.8935. So correct to 3 decimal point answer is 0.89894. These answers are, none of these answers are similar to each other. X4 is 0.4664. Answer is 0.466. Right. Then X5. X5 is 0.3696. That is 0.3 7, 0. So still the answers are not similar with the x6. Yeah, 0 0.356 0, sorry, 61, actually 61. Answer is 0 0.356. Now you can see it's kind of a convergence. You can see, I don't know whether like it's exactly that is a convergence. We just go ahead with this x7 is equals to 0 0.3545, 0 0.455, sorry, 0 0.355. Now it's coming a little bit of a closer, seems to be, we'll see with that. So the answer is 0 0.354243 actually. So this answer is 0 0.354. Still it's not similar with it. It's kind of close, but you cannot say it's, because sometimes at the next level it might be totally changed. Yeah, but it does not make a problem. Here it's 3.542. That is 0 0.354. So you can say root is 0 0.354 correct to 3 decimal points, right? So what you can get from here to the, now you can see we have start, that is the point where I want to highlight in this question, right? If you start with, what is the point we started with x equals to 4 with it, but you can see it was came up to where some kind of, it's like 4 means definitely it should be in between 4 to 5 or 4 to 3. That is how that is how you get the boundaries. No? But finally, it was come up to a root where somewhere exists somewhere over here only, right? So that is a one. That's another point, another disadvantage where we see with the iterative formula. Sometimes you are going to find some root in between certain boundaries, but it was come up to a different solution for this quadratic equation starting from, if you start with this iteration formula. So that is the another one in disadvantage where we come across with this iteration formula. First disadvantage is sometimes it takes long steps to get certain significant answer. Other one is sometimes if you're starting, you need to find a root between one specific boundary, but it is end up with a value where with another boundary itself. Those are the disadvantages over here. Right? Right, now we started with this, the first, for the first part of it. For the first iteration formula, we started with x naught equals to 4. Now let's see what happened with if you use a second iterative formula. Second iterative formula is x equal to 6x minus 2 square root of it. Xn plus 1 equals to square root of 6xn, it's minus 2, right? Okay, minus 2. We'll start with x naught equals to 4. Therefore, x1 is equals to square root of 6 times of 4 minus 2. You can replace x naught 4 into that formula. Okay, so you can say square root of 6 times of 4 minus 2. That value is 4.2, sorry, 4.6904. So correct to 3 decimal point answer is 4.690, right? Okay, then x2 is replace that answer into this, that is turn up to 5.1129, that is 0.113. Then x3 is 5.3551, that is 5.355, right? The next answer is for the x4 is 5.8, sorry, 4891, that is 5.489. x5 is 5.562, 5.5619, sorry, it is 5.562. x6 is 5.6010, that is 5.601. This is actually the point where it's put in. x7 is 5.6219, that is 5.622. x8 is 5.633. 6331 is 5.633. X9 is 5.639. C 5.639. If you go a little bit further, X10 is 5.6422. That is 5.642. X11 is, yeah, 5.6438. It is 5.6, sorry, 5.644. Now it seems to be kind of a little bit of a closer, so it might be getting, yeah, there. Hopefully X12 is 5.6447, that is 5.645. X13 is, I think it's there, 5.6452, that is 5.645. Now you can see, so you can say solution, the root correct to 3 dp is equals to 5.645. So starting with, but you can say it is starting with 4. So we are expecting to get a solution in between 5 to in between 5 or 3, but you get a solution at another end. So this one also, like if you want to get the solution in at a kind of a close to 4, won't be much reasonable with this answer. That is the other fact, because from this answer even we didn't see a clear solution which is remaining close by to 4. That's the fact we don't get it. Right. Okay. Now let's start with the third formula. 6 minus 2 over x. X n plus 1 equals to 6 minus 2 over x n. You're starting with x naught equals to 4. You can say x1 is equal to 6 minus 2 over 4. That is turn up to 5.5. So we have to go ahead a little bit further. X2 is equal to 6 minus 2 over 5.5. So we'll work out and see 6 minus 2 over 5.5. That answer is this bit 5.6363. So correct to 3 decimal point answer is 5.636. So it's not similar to this. This is 5.500. It's not similar. X3 is, it's 5.645. 5.6451, that is 5.645, that is x4 is 5.6457, that is 5.646, x5 is 5.6457. That one also 5.646. Now what you can understand today, from this equation you get the solution much closer to that, but still there's a problem. We get not a value, almost like we started this iteration formula. So the value what you can, from this iteration formula you get the solution from a less number of steps. You'll be able to get the solution for the first solution. That's what you have to understand. Okay, now if you start with this question, fx equals to x squared minus 5x minus 3, show that fx equals to 0 can be written in form of this. So you can write x squared minus 5x minus 3 equals to 0. Here the square root is there. Therefore, I just bring this 5x minus 3 to other side. It's plus 3. Therefore, x is equal to how much? Square root of 5x plus 3. So that is the answer for this particular. So if you start with this, you can say it's like this: x squared minus 5x minus 3 equals to 0. I just bring this 5x to the side because there's a denominator 5 here, minus 3. Therefore, you can say x equals to x squared minus 3 over 5. So after that, you can use the same technique to obtain the answer for part B. I think that is not that hard of a question. Right, okay. We'll come up with this question. fx equals to x squared minus 6x plus 1. Show that the equation fx equals to 0 can be written in form of this. So answer for this is, its a square root is there, therefore you can write minus 6x plus 1 equals to 0. That is x squared equals to 6x minus 1, x equals to square root of 6x minus 1, right? Sketch on the same axis the diagram y equals to x and y equals to 6x minus 1 square root of it, right? So you can just draw this y equals to x and y equals to 6 minus, just we'll draw it here. What we need to draw it, y equals to x and y equals to square root of x 6x minus 1. So if you just sketch this graph, you can understand that y equals to x line is just like this. So y equals to x line. And square root of x graph would be just like this. It traveling at, they have not specified with the, yeah, right, okay. So 6x minus 1 means it's traveling from 1 over 6. So the graph is like this. So from this equation, you can say, write down the number of roots. Number of roots we can expect is from the apathy. You can expect one solution from here and you can say two solutions. We can expect two solutions from this iterative formula. That's answer for part B. And yeah, use your sketch to explain the iterative formula xn plus 1 equals to this one, converge to a root of x naught equals to 2, right? Okay, we'll just do this. You can say xn plus 1 equals to square root of 6 xn minus 1. We need to start with x naught, root of when x naught converges to a root of fx when x equals to 2. We just start with this x naught equals to 2. So therefore x1 is equal to square root of 6 times of 2 minus 1. So if we just work out 6 times of 2 minus 1. So the first answer is 3.316. 3.3166. X2 is, if you just replace this answer over here, answer, it's turned up to 4.3472. X3 is 5.0084. X4 is 5.3899. Okay, yeah. That's, the next factor is x5 equals 5.5981. X6 is 5.708. 5.70866. X7 is 5.766. 664. X8 is yeah, 5.7964. I think now it's coming a little bit of a closer figure. This is x9 is 5.812. They expect us to find the solution. Yeah, right, converge to true. So you can see now it's come up like this here. It's turned up to 5.8 and here this one also 5.8. But with the correct first decimal point, it's turned up to 5.8 and this one also 5.8. So we have evidence to say, yes, it's converged to a 5.8 correct to one decimal point. So you can say solution converge to 5.8 correct to one decimal point. That's a way of getting this answer. Okay. The next one, fx over c also can be rearranged in the form of xn plus 1 equals to xn to the power 2 plus 1 over 6. By sketching the diagram, explain why the iteration diverges when x equals to 10 to the right. So you can say x, so the second, right, if you come up with this, that second iteration formula is for the xn plus 1 is equals to xn squared plus 1 over 6. Yeah, right. So that means you need to show, you have to get the solution by y equals to x is the one solution, another one y equals to x squared plus 1 over 6. So if you sketch these two graphs, y equals to x lines on and this is x squared. So if you just draw y equals to x squared graph is like this, and plus 1 over 6 means it's somewhere like it's at some kind of a point over here. It's traveling through 1 over 6 per day. That is a fact over here. You can say, now you can see between these two, you can see the intersection per day. We cannot see an intersection. Therefore, x naught t equals to 10 diverges and it does not converge to a solution. That's a factor to understand with this. Right? Is that clear? Hopefully that is fine.
Yes.
Right. So in this case, if you need to get this kind of solution, you can say fx equals to x e to the power minus x plus 2. Show that the equation fx to 0 can be written in form of this. That is, it's come up to ln. In that sense, what you can get here is when you get into this equation, x e to the power minus x plus 2. Over here, x minus 2 is there in one side. Therefore, I just write x e to the power minus x equals to, if you brought it to other side, turn up to x minus 2. Then we will get like this. So e to the power minus x is 1 over e to the power x to x minus 2. So with this you can write, if you subject e to the power x, it's turn up to x over x minus 2, because that expression is there over here. Then if you bring this ex to other side, what happens? Turn up to x equals to ln x over x minus 2. Why do we put this modulus mark over here? The reason is for ln value does not exist for negative values. That is the reason we used to write this modulus mark over here. Then fx as a root in the interval of minus 2 to minus 1. Use this iteration formula starting from x naught equals to 0, find the two decimal points. Find the value for x1 and x2. So you can say x naught is equals to minus 1. Therefore, x1 is equal to ln minus 1 over minus 1 minus 2. So we will work out here and get the answer ln minus 1 over minus 1 minus 2. This minus 1 minus 2. It is a starting point over here. So that value is minus 1.09. We need for 2 decimal points, but then writing for 3 decimal point is enough. It's 9, right? Then x2. That means you can replace these 2 points with the new answer. So that answer is minus 1.0369. Then x3 is equals to minus 1.0746. In this case, if you need to get the answer correct to 2 decimal points, but if you write the answer correct to 2 decimal points, this is minus 1.10. This is minus 1.04. This is minus 1.07. In this case, none of these values are similar. 2 consecutive values are not similar to each other. In such situation, we should write the last iteration as correct to that answer. So the solution becomes 1.07. That's a way of getting this. If they are not tallying, we get the last iteration formula for given significant value. That's a way of doing this question. Right. For this case, if you come up with this question, it's a general type of a question which is available in the examination. This is gx equals to e to the power x minus 1 plus 2x minus 15. Show that gx equals to 0 can be written in form of this. So over here, subject e to the power x minus 1 and then get this iteration formula. Then root for gx equals to 0 is alpha. Use the iterative formula for this one, starting from x not equals to 3, find the value for alpha. So you can find x1, x2, and x3 and to 4 decimal places and you can obtain this answer. That's the same thing what we did before. Now, when you come up to this question, how do you supposed to do? What you need to do is to get this answer, we are not using any kind of this iteration facts. We need to show the answer is correct to 2 decimal points. So we get these ones. We get 3. We did this in the first part of the lesson. To correct to 2 decimal points, they get 0.005. Right? Then add it. Then what if you add it, what do you get? 0.165. It's a one part of it. Then subtract it. Then what do you get if you subtract it? Turn out to 3.155. Then we will replace over here. Replace over here. Then you can get G 3.165. So what you need to do? Sorry, 3.165. So I'll do it in the calculator and get it today. So it's turned up to e to the power 3.165 minus 1 plus 2 times of 3.165 minus 15. So the first answer is this bit 0.044. Next answer we can replace 3.3155. Replace those two figures separately. So there you get the answer minus 0.062. So you can say the sign changes, no? Sign changes from positive to negative. So you can say since sign changes, root correct to 3 dp is how much? You can write 3.16. But there are some situation comes both become positive or both become negative. In that sense, what happens? These two values become so close to each other. It might be the first answer is 0.044. Other one is it can be 0.043 like or 0.545 like. So like that kind of a similarity also there. So either the sign can be changed or sometimes both in the same sign, but the values are so close to each other. Under those situations, we can say a root correct to that decimal point is that. That's a way of doing this kind of a question. Okay.